Okay, so now I'll be beginning with I'm sure this is section 4 of, let me see here what section this is. This is section, what section is this? Okay, well, I guess this is section 5. Over here there's no like curve sketching really required here. You don't really have to sketch a curve here, but the idea is we'll just be doing top questions here. There's like barely any actual proper grid questions. So I'll begin here. The diagram below shows the cross section of a hollow cone and a circular cylinder. The cone has radius. Okay, well look, we'll just draw this one here. The cross section here. Okay, now what we have and then we have a cylinder. The cross section of a cylinder that is also fit inside. Okay, so now we have this. Okay, now what do we do with this, right? We are given that the radius of the cylinder over here, from here to here, is 4.5. And this is radius of the cylinder. And the height of the cylinder over here, from here to here, is 9 centimeters. So we can find the volume of this cone if we wanted to. However, we won't be doing that. So over here, they said that it's just enough to fit this cylinder is just enough to fit this cone. So let's solve each question individually. Question A here says express H in terms of R and hence show that the volume of the cylinder is given by V equals 9 pi r squared minus 2 pi r cubed. So there's two questions in one. First, we want to find H in terms of R. How do you find H? Okay, well here it looks like we have a case of similar triangles here. We'll draw the dotted line like they did there. We'll take any half. I'll take the left half. And then we'll see here that in the cross section, the cylinder cuts off like this. Let me just straighten it and align it. And then we also have 4.5, remember, over here, and we have 9 over here. So what we know is that over here, they gave us that the distance is r, and they gave us also that the height is h, but only for the cylinder. So from here to here is just h. So now over here, we should know the similar triangles here. This is a right triangle. Okay, then this angle is, this angle we have here is shared with this triangle over here. And this angle over here is shared also with this triangle over here. I don't know how to explain it. Let's do like this: A, B, C, and we should follow similar triangles here. Here is right, and let's say like I'll take a point M over here and then K. So over here, MK is the top of the cylinder, it's half the top of the cylinder, in the cross section. So and its length is of course R, and we have to know the following. Let's see here. We should first know that it's a straight line passing just down to the base of the cylinder. Straight line, meaning it's right to 90 degrees. This is also a straight line. MK is also a straight line. We have our first similar angle. Sorry, we have two equal angles. So that means we can say MKC, angle MKC is congruent to angle ABC. What else we can say is over here, this angle, we're taking two triangles into consideration. We should just remember that KC is, I guess, the whole entire thing from C to B is 9. So we can say then that 9 minus H is the length of CK. Okay, so what we can conclude with another similar triangle here is this angle over here is similar to this angle over here. Like shown here, we can see here that this angle over here is similar to this angle over here. This angle over here is similar to this angle over here. And then since they're two triangles and they both share this angle over here, then these two are guaranteed to be equal. Like we have, this triangle here. Oh, God. We have this triangle here. And then we have the whole entire thing as our second triangle. Okay, so we have like two of our triangles here. This one and this one. So, yeah. And these two triangles both share one angle, which is this top angle right here. So, yeah. Sorry for the shaky handwriting. It's fine. So yeah, now we know that now we know the angles that they share. This with this, this with this, and this with this. So now we know that these two are similar triangles. So knowing that these two are similar triangles, we can then apply a ratio over here. We'll go back to our diagram here, and we'll just do the base of this, like AB, AB, and then over. I don't know. Well, let's say, for examples, we take the whole side CB, and then we'll face it with angle A. We'll take any angle facing a side. So let's say, for examples, we have angle facing, like angle C here. Angle C here is facing AB, is facing AB, which is 4.5 for the large triangle, and its length its adjacent side is just 9. So it's going to be AB over CB is equal to, and then we do the same idea here, where with angle C, we do the opposite, which is R, and the adjacent, which is 9 minus H. Or in other words, MK and CK. Now we write the actual values of AB, which is 4.5. We write the actual values of CB, which is 9. We write the actual values of MK, which is R. We write the actual value of CK, which is 9 minus H. Now we'll just cross multiply. I rewrote it as 1 over 2 instead of 4.5 over 9. I cross multiply now, like more comfortably. I get 9 minus H is equal to 2R. And they want first H in terms of R, so we isolate H. 9 minus 2R is equal to H. And then we have to prove that the volume... What is V? First we have to see what's V. What do they mean by V? V, what does V represent? I'm gonna assume V is just volume of the cylinder. Yeah, okay. Here, sorry, I didn't read it here. Volume of cylinder. So volume here, the volume of cylinder, we should know that the volume of a cylinder is equal to pi r squared H. We now know that H in terms of R is 9 minus 2 R. We simplify it, and then we get V is equal to 9 pi r squared minus 2 pi r cubed. So we get the volume. Okay, so now that we've proven it, we now have to show, now we have to find the stationary value of V. To get the stationary value of anything, we must derive it, and then we must set the derivative equal to 0. First, let's simply derive it with respect to R. So dV over dr is equal to 18 pi r minus 6 pi r squared equal to 0. And then I'll just simply factor. I can factor out 6 pi r. 3 minus r equals 0. So now we know the stationary values of r is r equals 0 and r equals 3. To find the stationary value of r, we must look at the range of values of r. I actually don't necessarily have to. Just find, given that r varies, r can be 0, r can be 3, just put r equals 3. Put the whole number. Put the whole proper number here. And now once we have r equals 3 and they want to find the stationary value of only V, we must plug in r equals 3 back into V. So you get 9 pi r squared minus 2 pi r cubed, and then you simplify to get 27 pi. So this is our stationary value of V. V is equal to 27 pi centimeter cubed. Okay, now I'll move on to another top question. In here, let's solve this one here. Now they stated here that there's a wire 10 centimeters long and it's cut into two pieces One is bent to form a square and one is bent to form a circle. So, we have to get the perimeter of each following shape. Perimeter of the square is equal to just 4 times x, which is 4x. Perimeter of the circle is 2 pi r. You add them and then it should equal to 10. Since they gave that to us right there. So now that we have this, they want us to prove the following over here. So if everything's x here, that means we want to find the value of r in terms of x, so then everything can be x. First, let's isolate r. So 10 minus 4x over 2 pi is equal to r. And then we'll just simplify to get 5 minus 2x over pi. And well, actually, no, this is the best possible simplification. And then we'll simplify it. We'll get the area of each of the following shapes because they want the total area of the square and circle. So we get here x squared and here 2 pi r squared. And we just add them. X squared plus pi r squared is equal to a. And then I'll just simplify x squared plus pi. And then instead of r, I put r in terms of x, which is 5 minus 2x over pi squared, x squared plus 5 minus 2x squared over pi. And then I make this x squared over pi, and pi of here, of course. Actually, I just put it on the other side. Plus 5 minus 2x in parentheses squared over pi. I expand 5 minus 2x to get 25 minus, so 5 times, so minus 20x plus 4x squared plus pi x squared over pi. And then I simplify it, so then I get only the coefficient of each power of x. So now I can get pi, I add pi plus 4, and there's x squared minus 20x plus 25 over pi is equal to the area. Now they want us to find the stationary value, to find the value of x for which a has a stationary value. In order to do this, we must simplify simply here. So we'll do here a dA over dx. Wait, first we'll simplify it so then it's easier for us to derive here. So dA over dx, or just dA first. Just a is equal to pi plus 4 over pi x squared. I'm distributing the pi. Minus 20 over pi x plus 25 over pi. Now I can derive here. A prime or dA over dx is equal to here 2 pi plus 8 over pi x minus 20 over pi. And then to get the stationary values of x, we must state here that the derivative is equal to 0. So we do just that. Then we just cancel the pi's out. 2 pi plus 8 pi minus 20 equals 0. Now, and I forgot the x here, of course. I put pi here, I'm supposed to put x. And then I just get x. 20 over 2 pi plus 8 is equal to x. Or in simplest form, 10 over pi plus 4 is the stationary value of x. Okay, moving on. We solved a and b here. We solved this question here for phi is equal to 27. Okay, so these two are done. Now, moving on, I'll be doing this one here. Sorry. Over here, they gave us that there is a wire and it is stretched around into a sector, meaning that the length of OP plus the length of arc PQ plus the length of OQ is equal to 20. So how do we get first the arc PQ? OP and OQ should be easy enough. OQ is equal to OP because this is a sector. In a sector, these two are equal. And over here to get the sector, we must do they said radians, theta radians. When they do radians, instead of doing the angle, like for example, let's say they said theta degrees, then we normally do theta over 360 pi r. 2 pi r. However, in this case, instead of using 360, we'll be using 2 pi. We'll assume that for each pi it's 180. So the theta over 2 pi multiplied by 2 pi r. These cancel, so that means for the perimeter, that means like in any case, this is just how the formula is gotten, but to get the perimeter of any like arc facing theta, you must use this formula here, theta r. Simple as that. I'm just stating here how to get it, and then later on you can apply this formula on any other question. So now we have PQ. We don't know what theta is. However, we do know that we can just plug in theta r in there. So PQ is equal to theta r. So and OP is equal to r. So we have r plus theta r plus r is equal to 20. So 2r plus theta r is equal to 20. And now they want us to find the area. First, we'll just find, they gave it all in terms of r. So now what I'll do is I'll get the value of theta in terms of r. So I isolate it. I get r2 plus theta equals 20. So I get 20 over r. 20 over r minus 2. And then that's equal to theta here. And then with the value of theta, I can find the area of this whole entire sector by doing... Now I'll show you how to get the area of any sector. We do same thing here, theta over 2 pi. Instead of 2 pi r, we do pi r squared. We cancel the pi's here, you get theta over 2 r squared. So that's our that's to get the area of a sector. With respect to theta, of course. And over here, our theta here is 20 over r minus 2. So we'll just replace, knowing that theta is equal to 20 over r minus 2, we can apply that 20 over r minus 2 over 2, r squared is equal to the area in terms of r. So we divide 2, we get 10 over r minus 1, r squared. You distribute the r squared, and you get 10 minus 10r minus r squared equal to a. So we have now proven that a is equal to the following here. Given that r can vary, find the stationary value of a and determine its nature. Now to do that, we have to, given that r can vary, so let's look here. Find the stationary value of a, we have to derive the area with respect to r, so dA over dr. To find the stationary value of a, we must set the derivative equal to 0. First, we get the derivative dA over dr is equal to 10 minus 2r. If you want to know if it's always maximum or minimum, you can just do d squared a over dr squared, and we get minus 2, which means that the derivative is always negative, and that means that it is always maximum value here. Anyway, we'll just find the stationary value equal to 0, r is equal to 5. So now we know that r equal to 5 is maximum. So yeah, here you can write r equals 5. Oh, and it is maximum. Okay, now moving on. The diagram below shows the dimensions in meters of a garden. The perimeter of the garden is 48 meters. So find the expression of y in terms of x. First, they gave us the perimeter, so we must add each following side. So 3x over here, plus y, plus 2x, and then plus what this length we don't know, plus x plus 2y. Given that this is a straight line, over here, and this is also a straight line. That means we can draw an imaginary straight line over here, an angle over here, and knowing that this little sector here then would be y, that means the other sector here would also be y, since we just do 2y minus y to get y here, and that means, and these two opposite sides are equal, so this side is also y. Okay, so now we have that side as y. So now we just add each one. We just added over here y plus 2x plus y plus x plus 2y plus 3x. And that is all equal to 48. Now we easily simplify. We get 2 plus 1 plus, okay, so 6x, and then plus 4y is equal to 48. They just want y in terms of x. We isolate y. And then we do this. I simplify to get, we get 12 minus, here it says 6, so minus 6 over 4x is equal to y. But if you want, you can keep it as is, or you might even want to just simplify it by 2 by just doing 24 minus 3x over 2. That also works. And this too also works. I'd prefer this one. So, given that the area of garden is 8 meters squared, show that A is equal to 48x minus 6x squared. So we don't have a certain formula to find the shape of this. However, we'll just individually split it into two shapes. We should keep that here, that this side is y. So given now that we have here two shapes, one is a rectangle, one seems to be a square. Since this side's over here, this side over here is x, so yeah, it's a square, but it doesn't really matter. We just multiply this by this to get the area of this region. And then we multiply over here, this side is x, which means, but it doesn't really matter because we already have 3x here. So here, it's just going to be 3x multiplied by y to get the area of this region 2. So we do 3x times y plus y times x to get the area of the two regions, which is equal to 3xy plus xy, which is equal to just 4xy. We are given that y is equal to 12 minus 3 over 2x. So 4xy, it becomes 4x and then 12 minus 3 over 2x. You distribute to get 48x minus 6x squared. Or if you want, you can just get 12 over 2x squared, which simplifies then to 48x minus 6x squared as the area. So equal to A. Okay. So now we have the area. We prove the area. Given that x can vary, find the maximum area of the garden. Show that this is a maximum value rather than a minimum value. So to show that it is maximum or minimum value, we must find the second derivative, and to find the stationary value, we must derive once. So we'll derive a once with respect to x. We get 48 minus 12x. And we have to set the derivative equal to 0 if we want to find stationary points. X would then be equal to 4. We don't know if this is maximum or minimum. To do that, we must derive the second time. And over here, it shows that it's going to be always negative, meaning that it is always concaving down, meaning that x equals 4 is a maximum. So here you just have to show that d squared a over dx squared will always be negative. And then you have to say x equals 4. Or if you want to find the maximum area, then you have to plug x equals 4 back into the original formula. So you have to do 48 multiplied by 4 minus 6 4 squared. You get 16. Okay, let me just do this on the calculator. You got 96. Wait, let me just double check again. Yes, you get 96. Okay. So this is equal to 96 here. 96 is equal to A, of course. A, just write A equals 96 centimeters squared. Or it doesn't really look like centimeter, it looks more like meter. So meter squared here. A equal to meter squared, 96 meters squared. And to prove the second question in part C, they said to prove that it's always a maximum value here. That means the second derivative will always be negative. It will always concave downwards. Now I'll be doing two more top questions. Question 38 will be my second last top question. Here they give us, they said that it's a metal plate consisting of a quarter of a circle and a rectangle. So what we'll do is we'll add they're not really asking for the areas. They just said that the perimeter of the plate is 20 centimeters. So to get the total perimeter, we know that the side's y. We'll get the sector through like just 1/4 pi 2 pi r, which is, in other words, 1 over 2 pi r for the perimeter of this quarter circle, and then this length here, and then this length here as well. So now we'll just add it all together. So x plus y plus x plus 1 over 2 pi r. R is equal to x in this case. X here, so r is equal to x. So first let's just simplify the other side. So 2x plus 2y and plus 1 over 2 pi x. So now I have this, and this should be equal to the perimeter, which is 20. Okay, and now they're first asking us to find y in terms of x. We must isolate y. 20 minus 2x minus 1 over 2 pi x is equal to 2y. Then we'll just divide. We get 20 minus 2x minus 1 over 2 pi x over 2. We get y equals 10 minus x minus 1 over 4 pi x. Okay, now that we have this here, we'll be plugging this into the area. Now, how do we find the area of the total plate? We just have to find the area of the two separate regions. We'll first find the area of the region of the sector, which is just slightly harder than the other part. Here it's just x times y. Here's xy. And over here we have to do 1 over 4 pi r squared. R is x, so we replace it with x. So now we need to get the total area is the first region plus the second region, and that's going to be equal to A. And now we found that y is equal to 10 minus x minus 1 over 4 pi x. We can substitute it or plug it into the y value over here. So 10 minus x minus 1 over 4 pi x is equal plus 1 over 4 pi x squared. Okay, so now I will just expand the x. I get 10x minus x squared minus 1 over 4 pi x squared plus 1 over 4 pi x squared. Oh, I put 20 here. I was supposed to put 10. So, and then these two, they cancel. You just get 10x minus x squared as the area. Okay. So with this in mind, we proved the area, and now they want us to find the value of x, which is stationary. So really easy, we just derive A with respect to x, it seems, and we must equal to 0. So dA over dx is 10 minus 2x equal to 0. X is equal to 5. So over here, x is equal to 5 as a stationary value. Now they want us to determine the nature and the stationary value of A. So we must put a 5 into first the original formula. So A is equal to 10, and then plug in 5 for x minus 5 squared. you get 25 centimeters squared as the area. We don't know if this is a maximum or a minimum. We must get the second derivative in order to determine that. And it will be equal to minus 2. Here minus 2 is less than 0, which means that it is concaving downwards, meaning that it is x equals a equals 25 centimeters squared, and it is a maximum, and will always be a maximum. Okay, now my last top question here. I might maybe pick another one. No, this is the only one I'll be doing then. So we have here a semicircle and a rectangle, and they told us that the perimeter is 12. It's practically copy-paste of nearly every question that we've done here. So we'll just quickly get the perimeter here. It's 2r plus h. Okay, sorry, we do have to double that here. So we first have to label them all, of course. 2r, sorry, there's h, there's 2r, and then there's the perimeter of the semicircle, which is just half pi r squared. No, sorry, just half 2 pi r. The 2's cancel, you just get pi r as the perimeter of the semicircle. So that means pi r is the perimeter here of the semicircle. So now we get pi r plus h plus 2r is equal to 12, because that's the total perimeter. You get then 2h plus 2r plus pi r is equal to 12. Now what we do here is get h in terms of r. So we'll do just that. 2h equal to 12 minus 2r minus pi r. And then we'll divide it by 2. And now we have h in terms of r. Now part B, show that the area of the window a meter squared is given by a equals 12r minus 2r squared minus 1 over 2 pi r squared. To get the area, we must find the area of the two separate regions here. So we have region 1 here, which is just simply 2r multiplied by h. We have the first region, and then the second region here is just half pi r squared, because it's just a semicircle. So now we just add these two areas here. 1 over 2 pi r squared plus 2rh is equal to the area. And we want area all in terms of r, as shown here, only r here. So 1 over 2 pi r squared plus 2r multiplied by 6 minus r minus pi over 2r. And then here, what we'll do, we'll expand the r. Minus 2r squared. And then we get minus pi r squared. And then we subtract and simplify, we get 12r minus 2r squared minus 1 over 2 pi r squared. By just subtracting these two, we're just adding these two, we'll keep this as is, and then we have area in terms of r. Not centimeter, it's meter squared. But they don't want that here, we just want to get until this point. Given that r can vary, find the value of r for which a has a stationary value. Now to get r, to get the value of r, we first have to which is a stationary value, we have to derive the area with respect to r, and then we have to set the derivative equal to 0. The derivative originally is dA over dr equal to 12 minus 4r minus pi r, and then we must set it equal to 0. We'll just find r. We'll just first let me simplify here. Then we get 4 plus pi multiplied by r is equal to 12. R is equal to 12 over 4 plus pi. Now that we have the stationary value of r, determine whether the stationary value is maximum or minimum. We have to find the second derivative of d squared a over dx squared. No, it's r, it's not x. And that's equal to just here, let's derive it here. So get the second derivative, of course. We'll get minus 4 minus pi, which is less than 0, and it's concaving downward if it's less than 0, meaning that it is x equals, sorry, not x, r equals 12 over 4 minus 4 plus pi is maximum, because it's concaving downwards. Now that is it for what I'm doing for this section, and I'll move on to the final chapter and the final section here, which is really not that difficult at all. I'll skim through it on the next video. Thank you.